Hello. We come to the final presentation of today, and thanks for coming. I know it's late afternoon. I would leave otherwise if I wasn't the last speaker. It's a pleasure to be here. It's an amazing conference. I enjoyed it. I'm a little bit tired by the second day. Anyway, so it's a nice city, and I love to be here. So the topic for today, I call the presentation How to Break the Software. And there's a grammar mistake. My English teacher told me it's how to break software and not the software, so there's an error. I haven't found it. So a little bit about myself. I'm not going to waste too much time. So this is me, Superman, and I'm doing software testing since 1998. And I'm a kind of software engineer since I was 12 when I decided to do some programming. And currently, I'm working for the financial domain. I'm not going to name the company. And practically, with my colleagues, we are counting money. And even today, I'm running a team of automation engineers. I'm myself doing some hands-on testing and data automation. We test some web applications, mobile application. I think it's very cool still doing some hands-on thing after 20 years. So that's me, still trying to kill as much bug as possible with my laser eye. So how to break the software, or how to break software especially. So today we are going to talk about a couple of things. This is based on my 21 years of experience as a software tester, test leader, quality engineer. We are going to cover a few topics. First one, what to learn, what to study to become a more efficient and effective software tester. So this is part two. Part one. Part two is going to be about an approach, a strategy, how to find those sweet spots. When you do when you test that part, you break the software, so you find a severe bug in the software. So when I was a little child, I was reading comic books, and I was thinking about one day probably I become a superhero. I was watching Hulk, and I wanted to be as strong as Hulk, fly like Superman, and save the lady. But honestly speaking, never happened. So I grew up at one point of my life. I realized that there's no such thing as a superhero. This was my idea till I joined Ericsson, and I met a few seasoned testers with 20 to 30 years of experience in software testing. And then I realized that we all have a superpower. Those guys with 20 to 30 years of experience in software testing, they were able to quickly spot those bugs in the software, like this. And I said, oh, there's magic. They do have some sort of superpower, right? And I understood that we software testers also have a kind of superpower. We have a sort of X-ray eye. So we can see through the graphical user interface and spot those hidden bugs within the software. So today's presentation can be considered to be a kind of superhero training camp. So hopefully, by the end of the presentation, you become a superhero as well. So information sources. Basically, I have a theory, and probably many people will hate me because, at conferences, many people talk about methods, processes, and tools, and they tell you this will help you become more effective and efficient software testing. But my idea that you have to learn and learn, because practically no process can replace your experience and your skills. I've seen dozens of agile introductions. All failed because the people were not skilled and experienced enough. I have seen people introducing test automation, and all of them failed. At the end of the day, they spent more time on test automation than on manual testing. So, my idea, if you learn about these topics, I brought up 5 different areas, you probably will have a better chance to succeed. So this is what my colleague knew when I joined that team of experienced software testers. So practically they knew software, the domain, the technology stack, architecture, and the users of the product. Let's cover all of this one by one. So, what I mean know the software. Obviously, bug history could be one point. Tricky parts, tricky interactions, complex algorithms, which easy to break. But I also mean the human beings who are involved in software engineering. Because you, as a software testers, you also need to understand not only the bug history, the complex part, the tricky interactions, but what other player of the project do, or more drastically, doesn't do. For example, when I was working for Ericsson, okay, probably I shouldn't name it, anyway, forget about it. So we have written like 15,000 system-level test automation test cases, which you may say that is too much, but we knew that we only have, so developers only do code review, and that's it. So we understood we are the final line of defense, and if we don't do something, then the software will be delivered with lots of bugs. What else? So, know the domain. What I'm talking about is, obviously when you are junior, it's okay to focus on the actual features, the features that your team develops. But as you grow, as you become more and more senior, you should understand the whole domain. Because usually, the piece of software you develop, only a tiny part of the system, the solution. And without a good understanding of the whole solution, you won't be able to efficiently and effectively test the software. I have 16 years experience in telecommunication and roughly 5 years in automotive industry, so that helps me to identify tricky scenarios in a software, regardless if it's a product of Siemens, Ericsson, or Nokia. Know the technology. Yep. I keep on hearing these days at conferences that from now on, we testers must be more technical. And I have to tell you, I disagree. Because we always should have been like that. When I started my career in 1998, we were supposed to be technical. We did automation. Not only the future testers supposed to understand the technology stack the product is implemented. But you also, because when you write automation, you need to understand the technology stack in use. Otherwise, you would be lost. Let's now go under a little bit under the surface. And I know many people question, okay, we don't have to understand the architecture. But I think you do, because my theory that if you become a senior software tester, you shouldn't over-focus on software testing discipline. You should have a good understanding of requirement engineering, architecture design, etc. And obviously, the users themselves, their behavior, their habits, and everything they would like, because I have been taken part in many projects. And in many cases, tech guys think that the user will use the software as they would, which is not true in most cases, I think. So, quickly, I think this sort of information will help you to become a super experienced tester. If you are a junior tester, forget about it. But as you grow as a tester, please widen your knowledge. Don't over-focus on testing, and don't over-focus on the single product you are testing. So that was all about what to learn if you want to become a superhero of software testing. So let's see what else we have. I named this approach fault model. Many people would say it's similar to failure mode analysis. It's not. That's more like an approach, it's model, how to identify certain aspects of the software that would probably break. When we develop softwares, we often forget about a few things. So, software under test is in the middle, in the gray box. But we often forget about that software, piece of software, executed in an operational environment. Operational environment means runs on a piece of operation system, hardware interacts with third-party systems, the user, and things like that. Obviously, it has certain capabilities and architecture. Again, I'm going to cover it more in detail later on. So let's discuss this more in detail. So I have a theory. Usually, software breaks for a couple of reasons. One reason, people. We have different, how to say, we lack different things. Knowledge, experience, attention. Then also, software might be complex. And also, the operational environment might be complicated, so diverse. So diversity, why is it a problem? My theory, if something is complex to design and develop by the developers, then you, as a tester, will have a great chance to find faults in the software. So I picked this mobile phone example. I don't know if you have ever think about, they are delivered with different screen sizes, with different operating systems. We may run the piece of software in different browsers, and you may display messages in different local languages. For example, when we used to develop car navigation software, we delivered that software to all regions of the world. So practically, we supported roughly 100-ish different local languages. And we're supposed to verify that many languages. And obviously, devs made mistakes. Because it was so complex, they were hardly able not to make any mistakes. And obviously, we have tons of vendors and models. And I don't know if anybody is involved in mobile testing. No, yes. Then you always have to have a good strategy, what kind of operating system version and device you choose. Because practically, you can't test your software on each and every platform version, and manufacturer. And why is it important? Because most of the vendors customize Google's Android. And if it wasn't enough, Android itself has, I think, 20 different versions on the market, still available. And it's a tricky thing, right? Which one to pick? Usually, you make a selection, but all you do is just reduce risk. But if you don't do it, if you don't have a strategy, you probably will deliver a bad product. Your customers won't be satisfied. This example is from my other company. We developed a telephone exchange, and we had a management interface. It was web-based. And we usually tested this piece of software in different browsers. Why? Because if you are not involved in web application testing, you may assume that they behave the same in different browsers. But they sometimes not. In our case, we tested a simple scenario. So practically, we logged into the management interface and logged out. And by pressing the back button, we were able to log in again. And what is the problem? It was a telephone exchange, so a person without any authorization could access the whole telephony network. That person could have shut it down for several hours. And it's a problem because you wouldn't be able to call emergency, an ambulance. Luckily, we have found this problem early. What's this? OK. I told you I was also involved in car navigation software development. And you may think it's easy, because it's all about navigation. We have a road, we have some crossroads, and that's it. But it's not the case. We had to build up some strategy by the years to cover all relevant scenarios. Up in the right top, we have tunnels. And we don't have GPS signal in the tunnel, but we have tons of such tunnels in Austria, and they often have multiple exits. And you're still supposed to navigate the driver to the right exit. Then, in New York, usually you don't have GPS signal between these skyscrapers. Still, your customers are supposed to get to their destination, right? And then we have these multi-level highways. And here, that's what some people call daily traffic. I'm not going to name the country, because I don't want to hurt anybody. But as you can see, there's no traffic light, lanes, and they don't even have house numbers. So by the time we have built up a huge database of typical scenarios by region. But it took us some time to create a strategy to cope with the challenges of such a diverse operational environment. So, what else we have? Honestly speaking, I can't pronounce this word. It's interoperability, or something like that. What it is. So, for example, if you develop a piece of software which is supposed to be part of a large network, like a router or switch, you're supposed to work with the product of different vendors. And you may think that, obviously, if they are based on standards, then they will work. But it's not the case. Because if you understand the basics of standardization, it's very slow. It takes like 5, 10 years. So what we did at Ericsson, we built a software based on assumptions. And at the end, we tried to update it with some success. And last but not least, you have users. And if you are lucky enough, you may have just a limited number of different types of users. But for example, a navigation software, a TV, they usually need to serve the needs of my mom, my grandma, my needs, and my son's needs. And it's very difficult. And practically, they have different kind of quality definition. But probably you have learned this, that all these are superheroes. The one on the left-hand side, it's a Japanese, American, and Eastern European. They're supposed to be similar, but they're not the same. Just an example from my personal career. Once we developed the car navigation software, we delivered it to US. They say, no, we don't want this. We want simple, clean design. OK, we delivered the same to Japan. And they say, no, we want video game. More information, realistic graphics, and we don't mind if we can't see the route. That was the idea. They said they don't mind much information on the screen. That's what we want. So we as a tester were quickly able to find faults in the software because we understand the different needs of the end user by region, by gender, and etc. Yeah, we are almost there. So we talked about the diversity of the operational environment. It can be diverse, but we often forget about a few things, like resources. The piece of software uses resources like CPU, memory, remote resources, and file storage. And why is it important? We are going to discuss it. They may run out. We may compete for resources with other processes, because we may run on a platform on which several applications runs, right? So let's see. Why is it a challenge? And why can we break the software by designing specific test cases? When we were developing software for telecommunication, we had to keep in mind one thing. That piece of software is supposed to run for 10 to 20 years. So if you understand that aspect of the software, then you understand that even a piece of hardware, a hardware component, may break. What else we had? File storage. This is a true story. Probably the most costful failure of mine, or fault, let's say. It was about, I think, several $10 million. Luckily, I don't make usually that kind of mistakes. So practically, I won't tell you the name of the mobile operator. It's in the top 3 worldwide. Yes. And one day, they had an escalation to the highest level of the management. Practically, part of the network went down completely. No phone calls in part of a region. We had an investigation, and turned out that the space ran out. And at that point, we said, OK, we are lucky because it's not our fault. And after further investigation, it turned out that the smart IT guy of the mobile operator ran a video sharing service. Practically, they created a service and shared videos within the firm. And they filled up the space and shut down the whole network. But you may think that it's not our fault. But yes, because we're supposed to deliver software which runs all the time. I don't know if you have been involved in telecommunication product development. No. Yes, we have a rule. We only allowed to go down for 2.5 minutes each year. So you can imagine. You have 365 days and 2.5 minutes downtime. So we're supposed to make a notification, a warning to the administrator, hey, Jude, you are running out of time, this space, which we didn't do because I didn't test it. So it costed the company a couple of $10 million. That's life, I think. We are learning from mistakes. And then also, our piece of software may access remote resources, and they might be low, running out. They may respond slowly, or never respond at all. That's also a scenario you're supposed to test if you know there's such aspect of the software you are developing. Yep. So this was the fault model I've created myself. So just to go through it again quickly. So we had this operational environment. Don't forget about it. Your piece of software is not in isolation. It usually runs on an operating system, may compete for resources, may interact with third-party systems. And don't forget one thing. Whenever you interact with a system, with a mouse or a keyboard, you usually do it through the operating system. So a few more aspects, capabilities. This aspect is usually covered by software testers, except sometimes this part. Even at my current company, they're thinking about to introduce this kind of testing, which is amazing for me in 2019. But there are a lot of companies who just thinking about to focus on non-functional requirements as well. So if you're a tester and join to quite a few of company, you might find bugs in the software if you test the non-functional requirements. Then you shouldn't forget about what your software usually do. Accept input, stores data, compute something, and produce data. And what I'm saying, we are not going to cover this capability stuff. I just picked a few interesting examples. Like, I don't know what will you do. If you can access a feature from multiple ways, would you test them? I would, yeah. Because, for example, in this case, you can do the copy-paste feature, copy-paste in several ways by short keys and from many, and sometimes they don't behave the same. It's simple. Then, as Captain America warns us, they may interwork, and sometimes it's quite straightforward because you may implement a state machine in the software. But sometimes this interworking is implemented by sharing data. Like the copy-paste feature, the first so copy stores something on a clipboard, then paste it from the clipboard. And complex algorithms. When we tested this navigation software, we had the most complex part was the route calculation algorithm, just find the shortest path. And you would think that it's simple. But if you would like to calculate a route from Budapest to Riga, it's quite complex, considering that probably the user wouldn't wait a few hours. And this single algorithm was more than 100,000 lines of code. And we knew it's very complex, and we knew if we focus on this aspect, it usually breaks, because the people, the developers, had difficulties to change it and to extend it. What else? Software architecture. Yeah, okay, this is from my telecom past. That's why I'm saying I think it's very useful to understand the high-level architecture of the software and major mechanisms under the graphical user interface and the API. I brought you a couple of examples. This one is software upgrade. I told you this software is supposed to run uninterrupted for 10 to 20 years. It's easy to understand. It includes software upgrades, right? In simple, what we did, we created the mechanism, but it was easier to say than implement. Practically what we did, during each and every upgrade, we created an instance of the process with a new version. We transferred the data and shut down the old instance. Okay, it was easy to say. I told it in 20 minutes, or 20 seconds, sorry. But usually it was so complex that we understood this is highly complex, so developers usually struggled to correctly change it, extend it, or play with this. So we usually tested this deeply, and we always find bugs in the software. Architecture. So this is more of the process view. It's a communication stack, a communication protocol. I told you, don't over-focus on the system level. If you are more senior, you need to have a good understanding of the underlying architecture, the mechanisms, and all sorts of these things. In this case, we understood that in case of the communication protocol, which was part of the telecommunication network, and this instance had 5 different processes, and we used this knowledge to design test cases. Because as I said, this piece of software is supposed to survive all kinds of failures, like when one board breaks or one of the processes dies and things like that. So we used this view, this aspect of the software to design test cases. And we have found tons of bugs in the software because it was so complicated. Yeah, so that was all. Let me wrap it up, what we had today. So different kind of information sources. Keep telling you that the people are more important than the processes and tools. So keep on learning all kind of stuff, your software, your domain, the technology stack, architecture, and obviously the way users use their software. And if you have a question how to understand what users want, what we did, practically we read reviews, because usually people write reviews, what they liked, what they didn't like of the product, or the same went for competitor products as well. Then we talked about this approach, and I think we do need to have approaches, strategies, because we usually work on complex products, and we usually work in a complex operational environment. So large projects, large and complex products. And I try to emphasize we have different aspects of the software, obvious architecture capabilities, but we also have operational environment. And don't forget about this, because in some cases, it's really important, unless your piece of software runs alone in isolation, which is rarely the case, I think, in today's world. So thank you for your attention. And if you would like to get in touch with me, you can do so. Usually, I do reply on emails and messages. So thank you again. It was a pleasure to be here and part of this conference. So big thank you. Okay, then we won't hand over the presents, right? You and me take it. Okay, here we have. I know it's late, so I appreciate your question.
Köszi a prezentációt. Just one question. You said something about the fall that you had in the telecommunications company. So it went down for more than the required time. What was the method that you did to fix this or to get the system up and running as soon as possible? So was there any spot, any place that you realized that, okay, this was it or this?
Actually, it was quite quick. It was more like a little bit annoying that we're supposed to cover this aspect, that we're supposed to send a warning to the operator. It was very quick because we did a quick health check, and just we checked the hard disks, and it's easy to realize that they run out. Investigating reason was more like just to complete the investigation, but anyway, when we realized that it ran out, we knew it's our fault. But the escalation wasn't that serious from that point. It turned out that their staff play with the equipment a little bit, and we had similar cases. I'm going to tell you. So sometimes if you work in a support organization, you will have crazy escalations, like people simply stealing some part of the equipment. It happened in Africa. They had an escalation, and finally we reported, hey, Jude, your guys just has stolen something. And they said, okay, sorry. Life's like that. Anyway, it was our fault because we're supposed to know we should write test cases on this aspect. We never ever forget it because it costed us several $10 million, which is far more than I will earn in my life. Okay, so he had the best question. So he won two. I don't know what he won.
That's a T-shirt. Yeah.
Okay, good. If no more question,
Yeah, there's one.
You were almost lucky. and won both T-shirts.
Hi, my name is Sergey, and I have a question regarding the routing. You mentioned that you have
The microphone. I can't hear you.
Sorry. You mentioned that you are working in automotive now, and so basically the question is following. How did you conduct the field testing of routing engine?
Sorry.
How did you conduct the field testing of routing?
Routing?
Yeah.
Okay. You mean routing in telecommunication?
No, in the automotive.
Actually, that was a navigation software, so we were not really, it was a little bit isolated thing. We run on a separate unit, so not so much. Yeah, we interacted with different sensors, or what do you mean? I mean,
what actually have been done as a test phase of the routing itself, if you did have a routing, of course.
Routing in automotive. In that specific case, we didn't have, actually.
So you just used the Google one, right?
Sorry?
You used the Google ones?
No. It was a proprietary. It was on our navigation software. So we designed a navigation software. We run on a off-the-shelf hardware. And anyway, after we can discuss it thoroughly. I can hardly hear.
Sure. Yeah, I'll come up afterwards.
Anyway, sorry. So.
I hope that's it.
No more questions, so one T-shirt is yours. The other one is yours. Thank you for coming. Hope you have had a good time.